So we covered in a previous video how to find the intersection points for these graphs here. And we're going to use those intersection points to set up the definite integrals that give us that area. Now, if you recall, the area can be represented as a definite integral from a to b of f of x minus g of x, where f and g are arbitrary, right? It could be k and h, or it could be q, it doesn't matter. But the thing to remember is that for what we're trying to do here, that area is always going to be positive. So we need f to be at least as large as g in that entire area. So we think of f as sort of the outer function and g as sort of the inner function. But really, you're thinking of one sort of being on top and one on bottom. So you have kind of a top and bottom function. So anyway, let's do a simple case. Let's do the case that we have here for number 1. We say that, all right, if I look at this, I can clearly see that the f of x equals x is the top function. It's what's going to be above x squared in this entire region. So I simply have to say, okay, well, I know my area then is from some a to b of x, so that's my top function, minus x squared dx. Okay, simple enough. Now what I need to do then is figure out what my bounds of integration are. What's a, what's b? Well, a is going to be your leftmost point, and it looks like over here the point 0, 0 is there, so we can say x equals 0, and the point 1, 1 is there, so 1. So in this case, the area is simply the integral from 0 to 1 of x minus x squared dx. Simple. You can't get easier than that, really. And we're not going to evaluate that, though clearly you could, and if you're feeling especially spry, go ahead and do it. The second one's the much more difficult one. So what we have here is that, okay, I'm going to start all the way at the left. All right. I have some sort of quasi-triangular, pseudo-triangular region. And then I have sort of looks like a Trivial Pursuit piece, if you've ever played that game. And then, of course, you have that same sort of figure reflected. Now, what you might recognize on this is, that looks like an even function. I could just do the right half and double it. You sure could. We're not going to do that here, though. What we are going to do is we're going to say, okay, I've got this point, this point, this point, and that point. Those are my x values. So now that I have the x values, I actually have 3 distinct regions. From -2 to 1/2 minus square root of 17 over 2. Then I have from that point 1/2 minus the square root of 17 over 2 to -1/2 plus the square root of 17 over 2. And then I have from that point -1/2 plus square root of 17 over 2 all the way to +2. So I have this region, and that region. You need, anytime you have n number of points, you have n minus 1 regions. Here you have 2 points, 1 region. If you had 3 points, you get 2 regions. You have 4 points, 3 regions. That's how it works. So what I've got to do is I've got to figure out which function goes on top, which function goes on bottom. So in this case, I got to say, okay, area then is an integral from, looks like -2 to 1/2 minus the square root of 17 over 2. Yuck. And then I got to figure out what's my top function, what's my bottom function. Well, on top here is the absolute value of x. And the bottom function is this 4 minus x squared. dx. Now integrating that's going to be a little more difficult because you've got to rewrite this in terms of that piecewise defined function like we did in the previous video. And then you'd need to distribute the negative and do all that. So I mean, it's going to be some complications in finding that integral, but it's relatively easy on the scale. So we have this integral. But notice that we stopped here. We didn't go all the way to here. Well, why not? Well, there's any number of reasons why not. But we have to do each of these as a separate integral and add the pieces together. So think of this as trying to find the area, sort of like taking change out of your pocket. You have to add a quarter and then a dime, and maybe the next one's also a dime, and then there's a nickel and whatnot. So you have to add each region piece by piece. And there might be a way to simplify it. In fact, there are ways to simplify this particular problem, but that's not what we're interested in. We're interested in figuring out how to set it up as segmented pieces. So the next segment starts here and ends there. So now we're going to go from 1/2 minus the square root of 17 over 2 to negative 1/2 plus the square root of 17 over 2. And I know that looks weird because this is the positive one and that's the negative one, but if you actually, did the math there, you'd find that this is actually a negative number and this is a positive number when it all adds together. Now, in this particular case, we have to look at this region. Which function's on top and which function isn't? In this case, the top function is actually 4 minus x squared. And the bottom function is the absolute value of x, right? It's the lower function. So we're almost there. We have one more to go. We now start here. That's our region, and then we have to make it all the way to 2. So we add negative 1/2 plus square root of 17 over 2, and we make it all the way to 2, and our top function is the absolute value of x, and our bottom function is 4 minus x squared dx. Now I want to point out one more thing to you. We're pretty much done, but one more thing I want to point out. When you're doing these types of regions, sometimes you will get it where like this red region is omitted and you're only getting the outside, sort of the wings there. But most of the time when you're doing these types of problems, it's going to be region, 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 and it's all one continual stream of x values. I'm pointing that out because the way to keep yourself straight is that you go from A to B, and that this number here comes down here. So you go from A to B, from B to C, and then this number is here, C to D. So A to B, B to C, and then C to D, right? So you just keep going up and up and up. And so that helps you keep track of those points so that you don't, again, it's just a bookkeeping thing. So do some of these practices. Obviously, your practice will make the difference here, but this is kind of a good start of a relatively simple and a little more complicated version.